Okay, so lesson 7.2 is talking about systems and how to graphically represent those. Some of them are word problems that we will have to write first as inequalities and then graph them. Okay, so this first one gives me 3 inequalities, and they ask me to graph the set of points which satisfies those inequalities. So we need to graph these 3, shade each of them, and then see where that overlap is. Okay, so let me get a coordinate plane on here real quick. And then we are looking at the first one, x is greater than or equal to 1. That is probably the easiest one. If it's x is greater than or equal to 1, that means it intersects the x-axis at 1. It is a solid line because it is equal to, and it's greater than. So I'm just going to kind of, in my mind, think about that. That would be this section over here. I don't have to really shade it in, just have an idea. This one, I'm going to solve for y, so I'm going to rewrite this as 2y is greater than or equal to x, so kind of flip it around. And then from there, y is greater than or equal to 1/2 x. Okay, so on this one, on that first one, it was just one variable, so that's either going to be a vertical or a horizontal line. In this case, it was vertical. This one has both an x and a y, so now I have a y-intercept of 0 in this case. And then I have a slope of 1/2, so up 1/2. You can also go down 1/2 this way. So here's my line for that one. And then that one was greater than or equal to, so that would be shaded upward in this direction. So right now my overlap is in this section right here. Okay, the last one, I can do this problem 2 different ways. I could solve for y and get it into slope-intercept form, or I could use my intercepts. So I could say, if I cover this one up, if I plug 0 in for x here, then my y value would be divided by 4, that'd be 3. So that means my y-intercept is 3. And then do the same thing for the x. My x-intercept would be 4. And then connect those 2 dots. The other option, like I said, would be to solve for y. So maybe you do this, and then divide by 4. So start at 3 and then go down 3/4. You get the same line. This one was less than, so it would be going this direction. So remember, the overlap over here was this section up here, and then I'm shading below this line. So that means this little bitty triangle right here is my intersection. That's my set of points which satisfies those inequalities. So I would shade that section in a little darker. Okay, so part B, they want me to find the quarter points of the set described in the by the system in part A. So they want me to find these points, these intersections. So those intersections are where they're basically the solution to these inequalities, 2 at a time, but I would make those equations because we don't really care about where it's shaded when we're looking for that intersection. We're just looking for that intersection point. So where are they equal to each other? So that first one was x is less than or equal to 1. I'm going to call that x equals 1 in this case. And then the second one was x is less than or equal to 2y. I'm just going to say x equals 2y. And then I can solve this set of equations. So I'm going to plug 1 in right here. So 1 equals 2y, which means 1/2 equals y. So that intersection point would be 1 was my x value, and then 1/2 was my y value. So at 1, 1/2, I should have an intersection point, and I do. It's between this one and this one. Okay, that's one of them then. Sometimes in these problems, they will ask you for specific ones. They'll say like, this point right here is point P, and we want you to find that point. So in that case, you just need to find the intersection of those 2 equations. My second set, let's stick with x equals 1 for a second. The other one was 3x plus 4y equals 12. Again, I'm using equals instead of less than or greater than because I'm just looking for the intersection. All right, so I'm going to plug 1 in there, so that'd be 3 times 1 plus 4y equals 12. So that's really just 3, and if I subtract 3, I get 9. So this one is not a great answer. It's kind of messy, but that's okay. So 9/4 is the same thing as 2 1/4. So my point here is 1 comma 9/4, but that's really 1 and then 2 1/4, which was right there. So that makes sense. I always check on my graph to make sure that these points make sense so that I know if I messed up. Okay, the last two I need to compare are these two right here. So I've got an x equals 2y and a 3x plus 4y equals 12. I'm going to use substitution again. So if x equals 2y, I'm just going to plug that in right there. So 3 times 2y plus 4y equals 12. So that'd be 6y. Okay, if I add those together, I get 10y. And when I divide, I get 12 over 10, or I could call that 6/5. Go ahead and simplify it. So this intersection point then, oh, I got to plug it back in. So I don't know my x value yet in this case. I'm going to have to plug this back in up here. So x equals 2 times my y value, which was 6/5, which means x equals 12 over 12/5. 12 over 5, I can't get my pencil to erase there. There we go. All right, so my x value is 12/5. My y value is 6/5, and it's okay for you to leave it like this, but to check it, you may want this as a mixed number. So 12/5 would be 2 2/5. So my x value is 1, 2, no, sorry, start from here. 1, 2, and 2/5 of the way. So like right here. And then I've got my y value was 6/5. So 1, 2, and 2/5 of the way. And then 6/5 is 1 1/5 of the way. So that's it right there. So that makes sense. Okay, so there's those 3 answers. The second problem in this lesson is a word problem. So number 23 in your book is what I'm going to look at for the example. You guys are going to do number 25. So 23 says the manager of a paper box plant is scheduling the work for 1 production line for a week. He can produce standard and heavy duty boxes. So those are my 2 types of boxes that I wrote down. I said standard and heavy duty. That's my X and my Y. And then he says each standard box requires 2 pounds of craft paper and each heavy duty box requires 4 pounds. Also, it requires 8 hours for labor to produce 100 standard boxes and 3 hours of labor to produce 100 heavy-duty boxes. So I wrote out on my pounds, we're talking about hundreds of boxes when you're talking about the labor. So I need to think about those in an equivalent way. So if I'm talking about 100 boxes for 8 hours of labor, I need to go back to my craft paper and think about, well, 2 pounds really means 200 pounds because this is each box. So I need 200 pounds to represent that 100 boxes. So when I'm looking at this, I'm thinking about this in 100 standard boxes and 100 heavy-duty boxes. That way I don't have to make this labor time a fraction because I don't want to do that. Okay, so that made this 200, this 400, this 8, and this 3. Then they gave me totals. Down here they said there are 50 tons of craft paper and 2,400 hours of labor. So the 2,400 hours is fine, but the 50 tons needs to be put into pounds. So 50 tons equals 100,000 pounds. Okay, so from there, I wrote my inequalities. So they told me, they didn't really tell me anything about my standard boxes. Those I just knew couldn't be negative. I couldn't have a negative amount of those. So it has to be greater than or equal to 0. My y value in this case, they said over here that The manager has a contract which requires him to deliver 10,000 heavy-duty boxes at the end of the week. So remember, if I'm talking about each of these, like my standard and my heavy-duty boxes as 100 of them at a time, that means that this 10,000 heavy-duty boxes really means 100 in my standards here because I'm talking about 100 a piece. So I just divided and got 100. So I have to have at least greater than or equal to 100 because that's what I have a contract to fulfill. Okay, then I wrote my next two. So I added these up and gave me that as my total. It can't be more than that. Same thing with these. I can't have more than 2,400 hours in labor. So I wrote that one. Now I need to graph all of that. So this one just asked me to graphically represent the set of choices available to the manager. So again, I'm going to make myself a XY coordinate here. I'm going to go ahead and push my axis over a little bit because I know I can't have negatives. So I'm going to go ahead and make it to where I don't really care about that negative section quadrant over here. Then I'm going to think about this in terms of like, let me find my intercepts real quick and then we'll see how far I need to go. But I think I need to at least count by hundreds here. So we'll see. All right, so this top one right here, I'm just going to write it again. So 200x plus 400y is less than or equal to 100,000. If I divide here my x-intercept, I'm just looking for intercepts here. So I'm putting equals. My x-intercept, if I divide by 400 right there, I end up with an x-intercept of 500. Am I on the right one here? 2, 4, 100,000. Yeah, my x-intercept would be 500, and my y-intercept would be 250. So if I covered this up and divided by 200, I got 500. If I covered this up and divide by 400, I get 250. So those are my intercepts. So I know I have to have at least 500 on my graph right now. I need 100 for this, 250 for this, and 500 for this. And then my second set, my 8x plus 3y equals 2,400. My x-intercept on that one would be, if I cover this up, I get 300. And my y-intercept, if I cover this up, would be 800. So I need up to 800 on my y-axis, and I need up to 500 on my x-axis. So I'm going to count by, let's see. I'm going to go every other line and mark it as 100. So I'm really counting by 50s, but I'm only going to mark my hundreds. So here's my 500. And then this direction, let's see if I can do the same thing. So 1, 2, 3, 4, 5. No, I'm not going to make it. So on this side, I'm just going to count by hundreds here. So this is 100, 200. $800. Okay, so let's go back up here. My x is greater than or equal to 0. That means it's only this direction. My y has to be greater than or equal to 100. So right here, y has to be greater than or equal to 100. So I've got this one and that one now as my kind of my axes that I'm going off of, just because this can't be less than 100. So now I've got this section right here that would be shaded in. My next one, which was this one, I've got an x-intercept of 500, y-intercept of 250. And if I connect those, see if I can do this way. I really need a straight edge. Okay, so that's a little crooked, but let me straighten it out just a little bit here because that's really bad. All right, this one was less than or equal to, so it would be down this direction. So right now I'm looking at this section right here that would be my overlap. And then this one, x is 300, y was 800. Connect those. And that one was also less than or equal to. So it's this section again. So that tells me that this is my overlap still. This is the only section that covers all 4 of those inequalities.